Our institute is a MindMajix, and we are a leading global online training platform, and we are holding 8+ years of experience in IT courses. And we do offer 500 plus IT courses in wide range of categories like project management, big data, business intelligence and analytics, cloud computing, data science, and many other programming languages and frameworks. And MindMajix provides all the instructors has a good number of experience like 5+, 10+, and they are doing a masters and good get clear people. So all the people are experienced here, and we train more than 410K students around the globe till now. And we do update our contents monthly just to give latest tech to the students, and we do deliver a best in class training for all students. And regarding machine learning training and certification course, and we do provide that. And what MindMajix does is we provide a machine learning complete course which includes all the algorithms and real-time application of that algorithms in industry level. And we do suggest you to how to get placed also with respect to certification, it will help you to clear certifications and to clear the interviews. Like that knowledge we can give with our training sessions. And these are the webinar topics. First, we'll go through introduction of that. How does machine learning works? What are the features? Why we need machine learning? What are the machine learning applications? Challenges, what we are facing with machine learning things. Now you may heard of artificial intelligence also. Then what is the difference between artificial intelligence and machine learning? Then we will go through examples. Then why do you use mainly Python? Why not R? And we'll explain you about the types of machine learning and different types of ML algorithms also. Then I will let you know what are the job things, how much salary it is for data scientist or data analytics kind of things. And then we'll at last we'll discuss about your questions. Okay. Till now, do you have any doubts, any questions? Adnan and Raj. Yeah, if silence means I consider no. Thank you. That's introduction. Let me give an introduction about machine learning. Basically, machine learning is the study of algorithms. Basically, they improve the performance of some task with their experience. Basically, it is something like there is existing of algorithms, and it will help us to train our model or develop skill to our model with that its study or its experience. That's what basically our learning of the machine. That's how the machine learns. That's called machine learning basically. And basically optimize our performance criteria using example data or past experience it does. And in this picture, statistics also comes to the picture. Basically, statistics means you may heard of probability, some t-test analysis, statistic, integration, derivations also comes into the picture when it comes to statistics. This is the base for all machine learning algorithms, that is statistics. And with respect to role of computer science, efficient algorithms to solve the optimization problem, to give a efficient algorithm to the industry. And we do evaluate the model after training it. I will let you know what is training, what is this model. These terms I will use later. Okay. So don't worry much. The basic machine learning is we are going to teach a machine with a data set so that it will learn itself. Now I can explain you how does it works, machine learning works. Basically, if you heard of artificial intelligence, machine learning is a part of artificial intelligence. Artificial intelligence is a big, it's like a sea. In that, machine learning is a part of it. In the machine learning word only it explains what is machine learning. It's like a learning, but machine learns that itself behaves like a working model. Totally of machine, if a learning machine is totally called as a model. Okay, what we will do initially, we'll train. Train means give continuous input data to a machine. Okay, we'll give continuous input data to a machine where machine means an algorithm. It is an algorithm. To algorithm, we give a data. So combining these two things, we can say a model. And we can check this intelligence of this model basically by testing algorithm. There exists a testing algorithm. We can test using those things. If while training, if model fails to perform better than like what we required, we may expect it should perform very well, very good, or it may, if you consider accuracy, I expect it should be a 90% accuracy, but it didn't perform like that. Then we can retrain it. Means I can teach that model again and again with a new data set or with a new architecture. I can train that model how I want it. See, if you see this flow, you can understand that the machine learning algorithm, basically it's the data we are pushing to machine learning algorithm. It starts learning when I train with my data set, it starts learning on that data set. That algorithm contains some building logic models and all those things. That is completely model is trained. When it's trained, it's completely done now. Now, if I give a new data to the machine, it should say or it should suggest output for that. Means it should predict output for that unknown data. So based on this, if it gives an improper result to that, in that case, I can come back and I can retrain this machine with the new data set or more data set. This is how we retrain. That is the term called retraining. When I train it, but model not performs that better, then I can go back and I can retrain it with a new data set or more data set. And I can change the algorithm also. It maybe my first time algorithm is not that efficient to for this application. I can change the algorithm and I can change the data so that it will give a required output and required efficiency or accuracy. Then what are the features of machine learning basically? Features means, as you know, features means like it is a what about machine learning? Same thing. It's not like that here. Features is a part of machine learning basically. Features means if I consider consider the image of a dog. If you see a dog image and if you see a cat image, the ears of dog and ears of cat changes. That is the features. If I consider features of machine learning with respect to a dog image or cat image, dog has 4 legs, body is big, huge size compared to cat, and its ears will be big compared to the cat, and the structure is different. These are some of the features of that dog. If I consider a cat, the different kind of that long hairs, that tails, then short legs, these kind of features comes into cat. So like that, it depend upon the data what we take. Okay, this completely depend upon the data what we take. Based on that, we will decide the features of machine learning. Okay, and there is comes a feature engineering only. It's basically to decide based on the data. We should think about what are the features we should consider for our training machine model. If the features are good, then our model will give good accuracy and it performs very well with the new data. See, these are the steps basically. We'll take the data first. It may be a dog image or cat image or numerical data. We'll clean that data first. We'll take the data, gather the data, clean the data. What clean means? When I'm considering a data of all dog images or all cat images, I should take care of such a way that there should be no cat in dog dataset and there should be a no dog in cat dataset. Each dog should be labeled or each cat should be labeled with cat name and with dog name like that. So we should clean data with improper data should be deleted. I don't want elephant into any one of these images. So it should be a completely dog images and completely cat images. So we should clean the data in such a way that it should be pure. I don't want a half dog or half cat. Some dog head is missing in that image. Some dog tail is missing in that image. I don't want such a data set. I want clear picture of dog and cat. Their position may be different. Some dog is standing, some dog is sitting, some one dog is running. So like that, the different position, it's fine. That is required. Basically, model will see different kind of images. That's what model needs, different kind of images, but it should be a dog only, it should be a cat only, so that particular thing should be exist. That's called cleaning of the data. Then comes feature engineering. Feature engineering means if I want to consider differentiate between cat and dog, my model should know what are the features it should consider for dog and what are the features it should consider for cat. So basically what algorithm does, it considers parts of the dog, maybe height of the legs or maybe the face structure of the dog. Maybe as I said, its ears will be big. So this kind of structure it crops and it makes the features for but particular dog. Same way it makes features for cat also. Okay. Then what we'll do in the next step, we'll define a model. Maybe model means I as I already told, it is a completely algorithm. We'll decide on a particular algorithm. If I consider cat and dog, I consider an algorithm of classification. I will tell you what is classification later, but in normal word, classification means differentiating two. Like cat and dog are there means if I give a new cat to the model, it should say it is a cat. Not it should not say it's a dog. It should say it's a cat. So that's what classification means. You heard of binary classification, right? Zero or one, it should be. So something like that. If I give a new data set to a machine learning model, it should predict whether it is a dog or it is a cat. Like that it is. Yeah, Raj Banshi, you said will you? Yeah, yeah. I will let you know regarding this. You will get the PPT or not. But surely I will help you to at the end of the QA session. I will let you know regarding whether we'll give or not. But if you have any doubts, you ask now. At the end of the session, I will surely let you know whether we provide you the PPT or not. This is about feature engineering. Then what we will do after defining a model, we'll start training the model. Training means give more data set to the continuously to the model. Show a picture of dog, show the picture of cat continuously for all the data. Consider 100 dogs and 100 cats. We start training a model with all the data set. When training is complete, then we will test with some of the data. Like if I consider 100 data set, we have 100 number of data set of cats, 100 number of data set of dogs. We will train our model with 80 dogs and 80 cats. Remaining 20 dogs and 20 cats, we will keep it for testing. Now I will show that 20 dogs to model, 20 cats to the model. It should predict all 20 dogs as dogs, all 20 cats as cats. If it does this, it is 100% accuracy, but never the model will be 100% accuracy. It will be some 90, 90 plus or 80 plus, sometimes it was 70 plus also. So depends upon the data, depends upon the algorithm, right? So something like that. So this is training and this is testing. How much the accuracy is more, that much efficient is your algorithm basically. Why do we need machine learning? Basically everyone says we should learn machine learning for improvise or tech is changing. Then why do we need, why machine learning comes into the picture? Basically machine learning is a programming computers to optimize the performance criteria using example data or past experience. That's what I say. Like I train it so that it will experience that data and it will learn based on that. It helps, it is needed when human expertise is not sufficient. It is not exist also. In that cases, machine learning comes to the picture. If I don't know, if I don't want to reduce my work, if I don't want to reduce my, if I want to reduce my work, I bring a robot to do that. What is this robot basically? Robot is completely a programmed model. It's a programmed model. If it is sees any chair, it says it predicts as a chair. If it sees a dog, it says it is a dog. If it sees a cat, it says it as a cat. It's completely trained model inside it. If you see inside your home, if a robot is there, if one of your family mother or father comes into that picture of that robot, it should predict that who is coming. Like if your father comes into in front of that, it says yeah his name or he is your father, something like that. It predicts that. So similar to the dog and cat, like it predicts that. So this is how the human expertise is not exist. In that case it comes into the picture. Consider a Google speech recognition. Even Microsoft entered into machine learning now. In healthcare, Microsoft has come to came into existence, showing that they should comes VR and augmented reality and virtual reality using machine learning, so that operations or patient handling should be done automatically. So machines will treat a patient, something like that it is. So it should be done in such a way that mm, person or a people can't do that. In that case, machine learning is very required. In biology also, if you want to know like a DNA test and all those things, previously in the like before 10 years there was a machines they used to start observing that completely how the DNA structure is in the machine. They used to observe that, but nowadays it's not like that. It's a completely machine learning models. If you give a blood itself, it says everything, like how many other people's DNA is matching with that, how much percent it is matching, everything it does now. So like that the tech is moving, that is growing with the machine learning and artificial intelligence. And what are the machine learning applications exist in the nowadays in the current industry or current environment? Basically automatic translation is there, traffic predictions are there. In Japan basically machine learning traffic lights are very much demanding. It's like you will get, as you heard of that, what is this signals? Basically, traffic signals are lights, red, yellow, and green. But in some of the countries like Japan, they are improving their tech in such a way that there will be a big screen comes in front of you saying "Don't cross the road" in the red frame. It's just like a TV. It says "Don't cross the road." Like that, it's completely machine learning, and there will be no person to handle those things. It is automatically done. That's how machine learning helps us a lot. And search engine results will be there, like Google does that, Facebook does that. And online fraud detection, yes, for detect the online frauds. Basically in the Twitter, if someone starts hacking or doing some fraud kind of things, it automatically detects that frauds. If in spam box in the email, if some spam site coming, means automatically machine learning what it does, it take all the spams into a different folder. It will not show us something like that. And in medical diagnosis like cancer, if there is a cancer, it automatically detects. If consider an example, if I go for some a normal checking, like if I consider normal checking means a PET, like a CT scan or MRI scan, they does for normal testing in Netherlands, in USA, in many other countries they does this. So when you go for normal checking, they do MRI and CT scan. Based on that, the model what it does, it is already trained on the all the images. When you show your MRI to CT to that model, it immediately says, it scans everything. It says you're having this problem. It's like you went for normal check, but you will get to know you have cancer or not. That's something like that. So machine learning automatically does that. It helps you to recover early and detect your some of the disease in very early stage, so that you'll be safe with that. So like that email, as I showed, image recognition, that robot, what I said, like that robot will be trained on machine learning. And text and speech recognition, here natural language processing comes into the picture. So these are some of the machine learning applications. Then now whatever I said is just like something like what are the benefits of machine learning, how we use that, how it helps us. But there are some limitations for that also. In 2018, a self-driving car from Uber failed to detect a pedestrian who was killed after a collision because this self-driving car was learning on a machine learning model. Basically, all self-driving cars are using artificial intelligence to drive itself. Okay, when it fails to do that, sometime what happens, model may misbehave. Sometime model may not be trained that accurate, that it may some different object comes into the picture which is not trained it before, it is not, which model didn't see before. If that object comes into the picture, it will fail to detect that. So in such cases some of the disasters happens. So we are attempt to use machine learning in healthcare with an IBM vaccine system failed to deliver even after years of time and billions of investments. Like in healthcare, this was a failure in IBM vaccine. Even machine learning approaches in particular can suffer from different database. That's what I said. If it sees a different data set in front of it or in test of that, the machine learning fails to detect that. So these are some of the limitations. I can tell you some other also. In healthcare data, measurement errors will be there. It will not be accurate. If you test a blood test, if it gives automatic things, sometimes it may be error, like +5 or -5 error will be there. Even temperature also, sometimes machine learning model detects all wrong information it gives. That's what I say. There will be no 100% accuracy in machine learning model. It may be 70, it may be 80, it may be 90, but you can't give accuracy. If it gives 99.9 accuracy also, there is a error called 0.01%. That is the error. That is the error which may lead to a death of a person. That's how risky with the machine learning. That is the limitation of that. And now we'll check like what is the artificial intelligence versus machine learning. That's what I'm telling, like how it is different from machine learning, basically artificial intelligence. Machine learning is basically a part of artificial intelligence. And there is, you also heard this deep learning also. The deep learning is in-depth working on multi-layered networks. Basically, you heard of CNN, convolutional neural networks. So these CNN and some RNN also come recurrent neural networks. These are the networks comes into deep learning. Other than that, whatever we treat with integers, whatever we treat with the numbers, whatever we treat with the images, classifications, regression, some of the algorithm, it comes under machine learning. Okay, so in-depth knowledge of in-depth coding of some deep learning things, means image kind of things, will comes into deep learning. That also comes under machine learning. So this is what machine learning. But what the artificial intelligence is out of machine learning. Basically, it's just like enhancement of machine learning. If you consider a robot is not only has machine learning model, it has many other components, many other technology which makes it a complete robot. But main part of that is machine learning. That's we should know. And I can give examples of that, like self-driving cars are there, and in healthcare, predicting the illness like a cancer, in financial industry, credits handling, in agriculture, even in social medias are using that, even spam emails, fashion industry like Amazon, Flipkart, Myntra, these people are using that. Even Walmart is completely using this machine learning for their handling their data. Then you can also know that there are many languages are there. Basically, there is a R programming language, there is a Python, there is C, there is Java, but people only prefer Python. Why not R? Basically, there is a say that the language which is who language like vastly distributed and you can freely access all the libraries, then that language comes into the picture. That's what Python is. Wherever you go, you will get a Python programming libraries. You can use those libraries easily to implement your application, and it is deploy deployable in all the platforms. It may be your Windows system, or it may be Mac system, or any system. You can easily deploy, and you can easily use that, right? So in such, that is the Python language. So more number of the developers are using this Python. And if you heard of Stack Overflow and many other Q&A related websites, if you see, more number of the questions will be on Python and more number of the answers will be on Python only. That's why like the people are interested in learning Python to learn machine learning or to learn artificial intelligence. That's where machine learning with Python comes into the picture. Basically, why Python only? Because it's reliable, it's having a very simple syntax. You can learn Python just a 7 days, like that much more than enough to learn machine learning. That's how it is. And you can work on deep learning also using machine learning, and you can develop web application, cross platform applications. You can develop video games. So these kind of like things can be handled with the Python language. So we do prefer Python programming language over R programming language. Okay, do I have any questions till now? Basically, Adnan and Rajbanshi.
No, so far is clear. Also, basically, I'm from art stream. So, you
Adnan, your voice is not that clear. Can you come again so that I can help you like answer your question? Your voice is breaking, Adnan.
hello.
Yeah, Adnan, tell me.
Okay, so far it's clear. Basically, I'm from art stream, not from a science stream. So, Your presentation is quite good and so far not out. Okay.
Yeah, sure. Thank you, Adrian.
Thank you.
Rajbanshi, do I have any like, do you understanding what I am telling or what I am suggesting? Is there any like any doubts with you till now? Yeah, no means you are understanding. That's what I consider. I will go ahead with explaining what are the different types of machine learning. There are basically main three types of machine learning are there. One is unsupervised learning. If you observe here, this is unsupervised learning. Don't look at all those things. Just look at this. Basically, main parts are three: unsupervised learning, supervised learning, reinforcement learning. Okay. What is unsupervised learning? What is supervised learning? And what is reinforcement learning? I will explain you. In supervised learning, every time what the data we give to machine to train, that will be labeled. Labeled means machine will know what the data is coming. Like if I give cat to the machine, machine knows it is a cat because I label that cat with a name saying it is a cat. If I give a dog image to the machine, I will name it as a dog. That is a label. So machine knows that basic names, that labels it knows. In that case, the supervised learning comes into the picture. So we call that kind of machine learning as supervised learning. Basically, we know the data. That means we know the data. It is a cat, it is a dog. We already know. We will train it. This is supervised learning. If we see unsupervised learning means it's opposite to that. We don't know the data labels. It's something like I have a data set. Consider I have a flower data set. That flowers have different kind of flowers. I don't know any flowers name also. I don't know any flower species also. I don't know anything. Just I have a data set of flowers. If I give that flowers to the my machine learning model, what my machine learning model does is it classifies all the flowers into a different category. It itself says these flowers are different, these flowers are different, means it classifies similar kind of flowers into one species. That's where unsupervised current comes into the picture. If you consider where we use unsupervised learning, you may see customer segmentation. Customer segmentation, many customers are there in the pool, but I want to segregate a similar kind of customers. Means maybe all males one side, all females one side, maybe all kids one side. That's with respect to age. If I consider any other criteria, it should be different. If I consider a country, all peoples of India on one side, different Russia, Australia, USA. So these kind of things are done automatically in unsupervised learning because we don't know what it is. So clustering comes into the picture, even dimensionality reduction comes into the picture. And there is another thing called reinforcement learning. This is a bit different from these two. This is what basically our robots use. What I know, artificial intelligence. This artificial intelligence basically takes both supervised and unsupervised also, but reinforcement learning also comes with the picture when robot navigations, skill acquisitions, when it learns different kind of tasks. If I want to develop a different kind of artificial intelligence based games, that time reinforcement comes into the picture. And where we use supervised learning, basically we use supervised learning in forecasting because we don't know the we know the we have the data with labels. That time we can predict the forecast. We can predict the future also, some kind of like a temperature, weather reports, this kind of thing. We can do that with that. And image classification, as I said, cats was dogs. Image classification can be done with supervised learning. So these kind of tasks which comes under supervised learning, and some of the data which we don't know, data details which we don't know, then we can do unsupervised learning. If particularly if I want to do a robotic kind of things, or if I want to do skill acquisition kind of things, then I should go to reinforcement learning, which is bit different from supervised and unsupervised. Now let's see. I have said algorithm means model. I said this because this is a heart. This is the heart of model. If algorithm is good, machine learning model is good. If algorithm is wrong, then machine learning model is wrong. Something like that. It is a must part for a particular model. As I said, there are three machine learning types in that: supervised, unsupervised, and reinforcement. Supervised, as I said, it is a different type of, because in here we do labeling. Labeling means we know the data details, what category it belongs to. We know that is supervised. In unsupervised, we don't know in what category this belongs to, but we have only data pool. We have a pool of data, and I want to bring out some signal structure out of that. Then it is unsupervised learning. Reinforcement learning, mixture of these two, basically supervised and unsupervised. So mixture of these two will consider for some different kind of application, maybe high level, high end, maybe game development or some robotic navigation kind of things. In robotics we use reinforcement learning. Let's see what are the algorithms comes in the supervised learning. There are basically main parts, four are there. One is the regression, another one is the decision tree, random forest, and classification. These are the different types of algorithms. In regression, there is a linear polynomial. These are algorithms. If I start, it will take a single algorithm explanation will take like one class, something like that. It needs 1 or 2 hours. So I can't explain each algorithm, but I can give a small idea on that. Like in regression, if you see, we stuck with the linear and polynomial. It's like an xy. Consider there is a weather, consider a temperature, room temperature is there, and in that temperature what is AC number should be. I have a data of AC number or AC point and a temperature. In this temperature this should be the AC, something like that. So when I'm creating relation between AC point, that AC number will be there, right, that temperature setting, that with the room temperature, I create a relationship between these two, such a way that automatically when I train the data to the model, automatically it detects that room temperature and it sets that AC. That is the relation between the two x and y variables, the temperature and AC. So that is called something called regression. That is a relationship. That is called basically, this is the two things. That is a linear basically. In the polynomial, the result is depend upon multiple features, multiple inputs. As now AC point is depend upon the temperature, like that there is something which is depend upon multiple features, like a salary of a person, salary of an employee depends upon his performance, it's his experience, his way of working, his way of submission. So these are the features. This is comes on polynomial regression. So something like that. Decision tree is also kind of that, but it is not regression. It's not relation. It's like binomial. You heard of the binomial things, right? If it is, if the age, if I consider a person age, I should categorize him whether he's the adult or he's a senior citizen. That time, what happens? I will consider his age, and if he is more than 60, then I will say senior citizen. If he is less than 60, I will say he belongs to some adult or like middle aged kind of category. So this is a decision tree comes into this. It decides yes or no, one or zero. Okay, these kind of things comes in decision tree. Random forest is another phase of decision tree, but it is a bit different and more efficient. And in classification, as I said, it's basically there are multiple classification, binary classification, all things will come into the picture. In this classification, there are some algorithms like KNN, K nearest neighbor algorithm, trees, that is a binary trees, multilinear trees, something like that. Then comes logistic regression, name-based algorithm, support vector machines. These are some of the names of the algorithm. We do use frequently these algorithms in healthcare industry, in like cart industry, this is a business industry, you can say e-commerce industries. So example, like Flipkart, Walmart, Amazon, these kind of industry, they more use KNN, name-based algorithm, support vector machines. This kind of classification they use a lot. Now let's come to unsupervised learning. There is comes a clustering, association, analysis, and hidden Markov model. It's a hidden Markov model is completely itself is an algorithm. And in clustering, there is a principal component analysis, support vector detector, K means clustering. These are the clustering algorithms. As I said, there is a flowers data pool. Consider flowers data pool. We have all flowers. It automatically, this K means algorithm or principal component analysis algorithm, it automatically detects these clusters in different way. Similar data is categorized into two or three. How much you give? that much category it does. Okay, if you give a k means is like something like if you did k as a 1, it will make a 1 category out of total data. If you give k equal to 10, like if you say to the model, I need 10 categories out of this flowers data, it gives us 10 categories of data, something like that. So it is depend upon algorithm and our input. Okay, so then reinforcement, there is the like no much algorithms completely based on the implementation. And we use supervised learning and unsupervised learning in this reinforcement learning. It's like a binding and creating output algorithm based on these two. And we use these things in a robot kind of things and game building applications where in this kind of things we use unsupervised and unsupervised algorithms only. And just to modify that and we hybridize that algorithms to bring a new and required efficient algorithm in reinforcement learning. And the main thing why we should learn machine learning and why the machine learning demand is growing day by day. If you see the data itself, it says there is 10.43 lakhs of machine learning jobs openings are available. If you see the hot property in that is 3 is to 2. If ratio of job available is 3, then the people who are searching is 2 means jobs are like day by day they are increasing, means requirement is there. Machine learning people are required in the industry. Why they need it? Because the tech is changing, technologies are changing, augmented reality, virtual reality, robotics, automation cars, automatic disease detection in healthcare industry, automatic selling, automatic teaching, natural language processing automatically. So these kind of things are developing. If you see next 10 years, the machine learning, artificial intelligence will be the boom. So everything will be automated and you can see a space cars. That will be the future, means automated space cars. Okay, so when these kind of things are evolving means automatically machine learning and big data comes into the picture. Okay, and if you see that like average salary of these people is also like if you consider US, and this is the US data basically, $91,876 basically. It's like a huge average salary itself is a good thing because people are demanding this machine learning just because job opportunities more and demand for them is more, and so they pay well because those are trending. So they want to grow their company means they should pay for that, like that. So it's very demandable a job basically, you can say. With respect to the skills, you should have machine learning is like a basic thing for implementation, or if you want to do something with artificial intelligence, machine learning is one of the basic language you should know. And if I see the job required, you heard of Indeed. Indeed is one of the job searching website. You see that each by each every year, like in every year, the requirement is coming out. More number of requirements are growing. So the demand for artificial intelligence and machine learning is growing each year by year. So if you learn now, you can achieve very well in the future. That's what I suggest. And our MindMajix gives you a really well structured machine learning course so that you can learn everything out of it, and it will be help you to get crack into a good company, and you can write a research paper on this kind of techniques what we teach. It's a very well and very updated technology and course what we predict. And we do experiment these things. We do work on these kind of things in healthcare, like in healthcare and kind of things. We do develop applications. I have experience. I developed multiple models based on real-time data. Whereas I have experience. I can give a promise that we can give a good knowledge and we can make guys expertise in machine learning. And now we came to an last and Q&A. If you have any questions, so that I'm ready to answer for you. So Adnan and Rajbansh, you can go ahead and you can ask if there any questions are there, please.
Hello.
Hi.
Am I audible?
Yeah. Hi, Raj. You are audible.
Thank you very much for your wonderful presentation, Natwa.
Thank you. Thank you, Raj.
To know how this IO thing is related to machine learning, sir.
IOC or IoT?
IoT, Internet of Things.
Yeah, Internet of Things. Yeah, perfectly. In the like now the technology is improving like very much, so that machine should interact with other machines also. That is basically you call IoT, Internet of Things, right? We do MQTT protocols, kind of things you do, right?
Yes.
So what machine learning model does, if I consider healthcare, like I will give an example how it is interacts. Okay, in healthcare, if you observe X-ray machines, MRI machines, now what is happening? There should be an employee or any doctor or nurse should be there to test each person, right? To do that.
Yes.
But if it is IoT is there means what IoT does, IoT will train a model, will integrate this machine learning model into IoT in such a way that it will replace a nurse or a person required for that particular lab. It will train in such a way that IoT will detect that particular patient is coming, and it will suggest to the a scanner or a X-ray machine, IoT device which you implemented and which you integrated with this machine learning model. It says to the X-ray machine, when he sits, it says X-ray machine scan him now. It will give a patient suggestion, please adjust your face, please adjust your body. So these kind of machines to machine interaction will be very efficient when machine learning comes into the picture. And machine learning, if I see now, like we are real in real time, I have a project where IoT comes into the picture in healthcare. That's like this is the future basically. What you are asking, IoT with machine learning, is a future basically, and it is very good question, Raj. And basically, IoT will surely will use machine learning.
Thank you, sir. Thank you, sir. Next one question can I ask?
Yeah, sure. Please go ahead.
You talked about many kinds of algorithms
Yeah,
for
yeah.
supervised learning, unsupervised learning, and all.
Mhm.
I'm wondering that how do we choose which algorithm we should go for?
Yeah, like depend upon your basically what is your requirement. If your requirement is can like give me a like if you do let me give an example. Okay,
Okay.
if there is a population means consider any population. If your requirement is something, I have only population data. Population data means I have all the data. It's considered like all males are there, females are there, senior citizens are there, like everyone is there. I have pool of data. If there is a project comes into a picture saying they need how many kind of male are there, how many female are there, how many citizens are there, how many senior citizen male and female are there, how many kids are there. You don't know, right? You exactly don't know how many are there, right?
Yes, yes, sir.
But in that case, what you will do, you will use unsupervised learning. Means I don't know any people, but what I will do, I will take algorithm. In unsupervised learning, there are some 3-4 algorithms are there. I will give you one. There is an algorithm called K means clustering. This what it does, it will take all the data. I already know there are only two categories. You know, right? Only there should be a male or there should be a female, right?
Yes, yes, sir.
Yeah, then what I will do, I will tell algorithm I need two categories. I will tell algorithm give me two categories. What it does, it will take all the data, it starts checking similar kind of people. If you see, female have different features, right? Maybe the female will be having that uh, you can say that hair kind will be different, with respect to men hairstyle will be different, the wearing dress style will be different. So these kind of things, what machine learning does, it categorize that males will be different and female categories will be different. When I get the output of that, then I will be having two categories, male and female. Now I got the requirement, right? If the project is like detect that, I detected that. But what helped? Machine learning helps. Which algorithm I choose? Unsupervised learning. Okay, this is the case when I do choose algorithms like K-means. This is one of the application. If I consider another application, like as I said, if I consider any example like you can take a cars algorithm. If you like cars, there are many cars are like they will move on the road, right? If you fix an IoT device, as you asked, there will be IoT device on the road. It daily tracks the vehicles, right? And it observes that vehicle. What I train to the model, if this is the car, it is a BMW. If this is the car, this is Hyundai. This is a car, it's a Audi. I train the model and I shown that model. If this car comes into your screen or in your video, if you capture this car, please consider that car as Audi and increment that Audi number to 1. So what model does, whenever it sees that kind of structured image, it says Audi, it says Maruti, keep count of that. At the end of the day, if you see that model output, how many Audis are passed in that road, how many Maruti, how many Hyundai, everything will come. This is called supervised learning. And the algorithm, what we use here, classification kind of algorithms. Get it? It may be a regression algorithm. It may be a linear regression. It may be a logistic regression. Okay. So these kind of algorithms we use depend upon the requirement. Okay.
Basically, it depends upon the data or the requirements.
Yeah, 100%. Basically depend upon the data and the requirement.
Okay, thank you. So finally, sir, you said that Python is used in machine learning. Can you formally explain why R is not used in machine learning
Okay.
kind of?
Okay. Sure. I will use. R is like, it's not like we are not using R. We use R, but R is, if you see R libraries and Python libraries, Python, the developers who develop Python libraries are more. The developers are more, and support is very much. Support means if you get any stuck in a machine learning library, if you want some data to train, if you want a new algorithm, if you want upgraded algorithm, you will not get that in R immediately, but you will get in Python. So developers are more and the requirement is more. If you go to R is basically, it's like already existing algorithms are there. It is basically used for statistics, for research
Okay.
people who does the research on that. They want to test on that. We do test, right? For testing purpose and to do statistical things are we use. Basically, if you consider, rather than building a machine learning model, if I want to do some statistics analysis, basically work on statistics means I want to take the application and I want to test if these people are similar to that people. I want to check the probability of that. I want to see the how this will differ. The statistics comes before training the model, right? So this statistic purpose we use R basically. For not training model, these kind of things we rarely use R because of the only big difference is it's Python popularity and Python demand in the industry, and already existing applications are in Python, and all the machine learning algorithms which people are developing, the experts people develop and leave it to the public to use those algorithms. Those are written in Python, basically not in R. So we do use Python more rather than R. And it's very
This
easy to
machine,
learn. R is a bit complex.
this machine learning is also dependent on statistics, no? Or am I
Yes, machine
wrong?
learning also depend on, yeah, machine learning is backend. If you see algorithm, why I said algorithm, right? Each
Yes.
algorithm is depend upon statistics. In this algorithm behind the statistics is there. Without statistics, machine learning is not exist. But these statistics things, what we do, it's already implemented in Python. If I want to test it, I will use algorithm. I will not use the statistics base. So who use these statistics? Basically, research people. Means if I want to test that, if I see, consider an example, I am a research person, I want to develop a machine learning algorithm. What I will do before developing that algorithm, I need to test, right? Like if I do this, how much it is giving the error, how much efficiency it is giving. So when I'm doing that, I use R only to test that. And to do use the different kind of statistics on that algorithm, I use R only. But when I implement it, if I want to use that, if I want to train the model or if I want to train data set on that, then I will use Python only, because Python is very easy. And Python, if you heard of TensorFlow, Keras, these are the frameworks. Okay, these are the deep learning frameworks. These frameworks are written in Python and C++. Okay, C++ they use only because it is the fastest running program. Means it uses CPU or GPU in very efficient way compared to Python. It is very efficient than Python also. But Python is very easy to understand and very easy to code. So what people does, they placement developers on top of C++, they write Python code so that we can develop a model or develop an application using this Python code. Okay, but R
Yes.
is used only in the statistics. Basically, you can develop a model using R also. It is fine. You can do all the whatever you are doing in machine learning. You can do in R. But R is you bit feel complex. You can't change it immediately. it's not that reliable also. If you want to cross platform, or if you want to deploy it into a cloud or in somewhere, so there may be some issues also with the R. But with respect to Python, it is not that, because everyone is using Python, so will be very easy for us to handle with this Python. So we use Python for that.
Okay, sir. Thank you very much, sir. Thank you very much for your client explanation, sir. Thank you very much.
Yes, sure. Thank you, Raj.
Okay.
Adnan, do you
That
have
was a
any
good.
question?
Oh yeah, I have. Can you
Yeah,
please
sure. Tell me,
share
please.
how the data science is related to the machine learning also, and how the supervised learning is related to data science?
Okay. First, second one is how machine learning related to data science, right?
Oh yes.
Okay. First, I will ask your second question, second answer. Can you repeat your first one? Later, you can ask that. First, I will answer this one. How data science is related to machine learning?
Oh, that's the
Data
first
science is
one.
just yeah. Okay. First, I will answer first one. Data science with machine learning. Okay. Machine learning is what real time. Real time means what we do. What we do means practically what we code is machine learning. But data science is just a concept. Concept means machine learning is a part of data science. You can say part, or it's a concept. Machine data science is just like a concept, like you say environment, right? Environment, but trees, cars, temples, homes, these are the objects. So total environment. So like that, data science is something environment. In that, machine learning, artificial intelligence, natural language processing, deep learning, these are kind of the objects you can press specifically. We do use that. Practically exist. But data science is something like invisible. It's invisible, completely invisible. That's like just a concept, you can say.
Oh, okay. So the data science is an inclusion of Python or machine learning algorithms, yes, isn't it?
Yes, exactly.
Okay. Then
What about
my
your
second
second
question:
question?
how the supervised learning is related to data science, or the Python using Python in supervised learning? How?
Okay, supervised learning and data science, right? You are telling
How when we are working with Python, that's how the supervised learning is related with.
with Python, right?
Oh yes.
Yeah. Okay. Supervised learning is a type of machine learning. Okay. Supervised learning, unsupervised learning, reinforcement learning. These are the types of machine learning. In supervised learning, we do this is a concept. Basically, supervised learning is a concept. In the supervised learning, we have algorithms. Basically, again comes to the algorithm. These algorithms are written in Python. And if I want to develop a model, I do code in I could do code in Python. Like if I want to develop an algorithm, if I want to use an algorithm, I do code in Python. What is this supervised learning is, we can use some of the algorithms in this. It may be considered an algorithm called KNN, K nearest neighbor algorithm. Okay, it's an algorithm. This algorithm is depend upon supervised learning. Supervised learning means there should be labels for the data. Okay, but the doing what we do, what we code and what we develop is in Python. Python is a programming language what we use. Supervised learning is a concept. You got it right. Supervised learning is a concept. Supervised learning, unsupervised learning, reinforcement learning, these are the concept where they categorize the algorithm. Supervised learning needs the data set should be labeled. Unsupervised learning needs data set should not be labeled. Reinforcement is mixture of these two and behaves in different kind of manner. But what Python is, wherever you go, if you go supervised learning or if you go unsupervised learning or you go reinforcement learning, you will do coding in Python only. You got it?
Okay. Thank you, Raj. Okay.
Yeah, sure. Welcome, Adnan. Any other questions, Rajvansh and Adnan?
No, sir. Thank you very much, sir.
Yeah, thank you, Adnan. Thank you, Raj.
Thank you very much, sir.
Thank you so much, and we for
This
your
conference
participation,
will now
Raj
be
and Adnan.
recorded.